Hi. It's been a while since I posted a video for this class, and I apologize for that. I was having some live stream issues. Some of it was pertaining to my Raspberry Pi, some of it was pertaining to the fact that I couldn't get my live streams to work. So, yeah, so I just kind of disappeared for a while, but I'm back now. And what I wanted to do today was I wanted to talk about Raspberry Pi coding for your project. Now the way that the rest of the way that the rest of the semester is going to work is that we're going to focus primarily on this project. I may give you some reading assignments and some quizzes, but I am not going to be giving you homework assignments, and I probably will still be giving you some lecture videos, as we haven't covered some information that I feel like is really critical for the class. We really got behind in this class, and a lot of it's my fault because I did not manage time well. I wasn't expecting the semester to go this way. COVID has really made this entire process a massive pain. So yay! What I'm going to show you now is just basically how to code your Pi to handle programming for your inputs and your outputs for your system. Now, I will say this, I'm not going to show you everything. I am not going to sit down here and do all of your coding for you. We have 3 weeks till this final, and if I do your entire coding for you, you will have nothing left to do for the next 3 weeks. And you won't learn anything as far as programming goes. So I do want you to struggle a little bit, and I will expect to give you time to do this struggle. Okay? Now the next thing that we need to address is those little Raspberry Pis I gave you are too small. They can't access the internet. They can't download the file that we need from them. So if nothing else, you're going to need to download the file on another Pi. If you can do the programming elsewhere and transfix it to your Pi, that's fine, but really I would like you to what I would do is I would do it on a different Pi and then come back later and put it on your actual Pi. I've put the hardware, the displays, the cables needed. I have put those in lead 248. There's, I think, 6 stations there. You can just walk right in, hook up, get set. I did tell the Thursday class this also, but the little power bricks that I gave you with the USB output, they're not powerful enough, so I ordered a couple more that are a lot more powerful. They should be here by next week, so if you're having trouble getting anything to turn on, it's my fault. But we'll plug those into the USB power supplies and have those running next week. Okay, so before you can start coding on your Pi, again, I'm doing this on my Raspberry Pi 4 because it's a really robust Pi, and quite frankly, I can access the internet with this. And the connections are a little nicer. Connections on the mini Pi kind of sucks, which we will find out if you want to plug that in to an HDMI adapter, which we can do next week. FYI, I will not be around tomorrow, so don't come looking for me. You are free to work. Please make sure you shut off any soldering stations that you turn on. That is absolutely critical, but I will not be there. Okay, so the first thing you should do with your Pi is make sure it's connected to the internet. I had to do that already. Next thing you're going to want to do is sudo apt-get update. This will produce some fun text. I've already done this, so it's not nearly as useful. And then sudo apt-get upgrade. And when you type that in, hit enter, it'll update your Pi. Okay, that's really important that you do both of those before you even start, because an up-to-date Pi is a healthy Pi and is a happy Pi. Okay, the next thing that we need to do is we actually need to download the Python library file for the ADC chip. So this is an ADS 1115 ADC chip. And I'm looking specifically at Adafruit because I know it has examples and sample code for it. They've already written a lot of this information out, both for use in the Arduino and for use with the Raspberry Pi. So this is the ADC chips that we purchased. I got them a little bit cheaper than what Adafruit's selling them for. But the beauty of this right here is Adafruit has a site on how to actually code with an existing Python library built specifically for the ADS 1115. Okay, and as you walk through this entire thing, it'll tell you how to wire to it, how to connect it to an Arduino, which we're doing it to a Pi. And it'll talk about what each of the different signals do, and you can just really jump in here and crunch. Here's Arduino code for how to run it. I mean, this is an extensive database of information. Now we are using Python, and with Python, this is it's a little bit nicer. Now I don't like using CircuitPython because it can be kind of a nightmare. So usually what I end up doing instead is it's the pip3. Oh, I gotta say sudo install, and I'm gonna go over here, and instead of looking through the CircuitPython, which is Adafruit's special library, I'm just gonna search this, and there is a GitHub code for it right here. Okay, and sometimes you can even find on pypi.org. I believe that's right. I'm having a hard time saying this because we're doing this on my laptop, so I have no idea what I'm actually typing here. Whatever I typed in, it was not right. pypi.org. Okay, and then I'm just going to look for the ADS 1115. Now there is a GitHub method of downloading it, but here the ADS 1115 does have an existing library. The code for it is pip install ADS 1115. So there are other codes of doing this. So that's 3 different ways that you can download this. One of them is from GitHub, which you can find here. Here's the GitHub file for it. It'll explain how to download it, how to install it. Which I guess I can click on that. PyPy is a pip install method. You can do the Adafruit method, which involves CircuitPython. All of these will give you different methods of doing it, but the way that I tend to like doing it is ADS 1115. Now I have to use pip3 instead of pip, because pip only collects the Python 2 version of it. Pip3 installs Python 3 version. It's one of the fun things about Python. So I'm also going to do sudo pip install ADS 1115, just because sometimes it requires the Python 2 version. This may give you errors. However, it may also work. Claims that it worked. Doing both of those methods, usually pretty robust. The next thing we're going to need to do is we're going to have to create a new Python program. So I'm going to go ahead and open up Thonny. Thonny isn't my world's favorite, but I do love it. Oh look, it's the EGR 325 file. I haven't used this Pi in a while. Always put pseudocode in. So my pseudocode is going to be this program runs a light controller, etc., etc., etc. I'm going to try to speed this process up. So fill out your pseudocode up at the top, explaining what the program is, what it does, etc., etc. So as far as inputs go, this has four inputs through the I2C ADC chip. Okay. As far as outputs go, this has it has 3 GPIO on-off light outputs, and it has 1 PWM GPIO output. Okay, and that's for the for power regulation. Okay, so again, pseudocode. I like putting in pseudocode because it helps you understand when you go back on this later and somebody else needs to adjust it. Pseudocode is just always a good idea to get in the habit of doing that. So the first thing we're going to do is we're going to go ahead and import a number of programs. I'm going to go ahead and import ADS 1115. I'm also going to go ahead and import, let's see, we need, I don't know, maybe time. You might need import SciPy, and you may need to import whatever the other one is. I don't remember it. But you may need to import all of those depending on what your program wants to do. Okay. One thing you will have to import is import rpi.gpio as a GPIO. Okay. And now what we're going to do is we're going to go ahead and set up our programs. Now, I don't actually remember how to set up the rpi.gpio, so I'm going to jump into, I'm actually going to jump into another program real quick and look at it. I've already got that one open. I might as well just jump in there. So, look, it's right there. Yep, rpi GPIO as that. You establish your pin numbers. So, and then it's gpio.setMode and gpio.setup. Okay, I'm just going to copy that code. You can copy my code. I'm just doing it the cheater way because you can find this stuff online, but I'm tired. Okay, so before we're going to do that, I'm going to establish pin numbers, and here's where you set your inputs and outputs. Okay, so I'm going to have red be equal to, I don't really know, 21. I don't have my list of pin numbers here. I guess I could just look at this. I'm going to do 23, 24, and 25. Okay, so this is 23. Blue is 24, and green is 25. Okay, and then my power is going to be pin number 12. Okay, that's what we set up in class. So now what you do is now we set up pins. So we got our gpio.setMode instead of left. This is going to be red. Copy, paste, paste. This is going to be green, and this is going to be blue. Okay, And all it does is it sets the pin numbers that we've associated with those values to the correct values. Okay, so I got to make sure that 23 connects to red, 24 connects to blue, and 25 connects to green. Now 12 connects to power, and we do have to set up your PWM output. In order to do that, I'm actually going to jump in here real quick and type in rpi.gpio PWM. And what this will do is this will give us an example of how to use the PWM pin in Raspberry Pi and how to set it up. Again, it always says you need to make sure that everything gets upgraded. You can use the GPIO to make that happen. Here's a way to work with BCM, and you got your setup. It sets it up as a GPIO. We go down here, PWM. Okay, so this is set up as a PWM. They have a button input where they have an internal resistor that they're using, and they use pin number 12 as a value that says, okay, we need this percentage of power. Okay, so I'm going to go ahead and set up, pretty sure that's 12, not 17. No, they do. They use 17. 17 is the other PWM pin. So there are two PWM pins. You can use 12 or 17. I think I suggest everybody use 12. So just gonna go ahead and change this to power. And we'll refer to that as a PWM from here on out. Okay. So this is just setting it up. Now we have our outputs handled. We have our import handled, so it's bringing in the ADS chip. The ADS chip automatically goes and finds where the ADS is located using I2C technology. So when we go over here and look at, here I used pip install, so I will use this information. We go over here and look at this. Let's see, I want to see download files. Okay, and this should give you an example file where you can just view it. Ooh, it's a Pi Wheels file. Or you can download it. You can download these files. I think by clicking on them. Yeah. And then you can unpack them as you wish. There are a number of unpacking methods. We'll go ahead and open, and then inside, here's the initialization file. Going back to the root, here's README information. I'm not seeing the example files that usually exist here. The setup.py file is the one that is actually used to create it. There's supposed to be examples in here. Does not appear that there are. Not zip safe. Oh well. I guess I can go look at Adafruit again. Adafruit has a bunch of code. Adafruit does have this code in here. I believe it also does the import. Nope, it does not. The GitHub does. I think the GitHub does. And this should give an example for how to use it. So I'm going to have continuous measurements. Here is an example of a Python code that is used to do this. And it looks like instead of doing the ADS 1115. They actually have Adafruit ADS 1x15. To do that, I think you can 3 install Adafruit ADS 1x15. I think that's it. Yep, I already have a lot of those present. And if you hit the up button on the keyboard, you can go back to the most recent one and go ahead and do a pip install too, which usually is a good idea. And then you can do the examples from the GitHub file because it uses the Adafruit 1x15. So this is the information I'm going to give you for right now. Again, I will not be around tomorrow, but you will feel free to email me. I will try to get back to you as soon as I can. Good luck. Yeah, I guess one more thing. I was about to quit the video and I want to say one more thing. You will have to have the ability to output which lights are active at what time. Okay, so you'll have a GPIO.out red, green, blue, whether or not they're on. Those are going to have to be controlled by what values are brought in from the ADC. Okay, the ADC is going to return a value between 0 and I think it's 2 to the 16th for the voltage that's being brought back from your 2 switches and from your photoresistors. So how do you use that information to control your Pi? Well, don't worry about the photoresistors yet. I want to actually deal with that in another video. But for right now, be focusing on thinking about how you can take that ADC input, break it up into chunks so you have like maybe 6 colors or 7 colors that you can pull out. You get your red, green, blue, yellow, orange, purple, white. So that's 7. What combination of outputs for lights do you need to get each of those colors? And how are you going to break up 16 bits of information, 2 to the 16th, into 7 nice, easy numbers so you can pull a switch to a location? I guess I can deal with that in another video too. But focus on getting your framework set up, getting that import to work. It would be a good idea to see that, you know, if you can actually get all of that code that I typed out today to work. Now I'll say goodbye.